I was a child of the space age, so planetary science came naturally to me. It was a form of science mixed with exploration, which I love, and I found the young and open nature of it exciting. Seeing things never seen before with little context meant having to sort through multiple hypotheses and never being certain of anything. Every day exploring how the bits and pieces work together and how they evolve. All these first-order big picture questions, very attractive to me. There's nothing incremental about it. You need the courage to be wrong, and yet you keep looking for answers anyway. A successful planetary geologist has to know enough to be dangerous across the whole span of the natural sciences. You have to be able to mix chemistry and astronomy and physics and geology and biology and even history while still keeping your mind open enough to processes that might be fundamentally alien. Planetary materials serve as a factual anchor amongst all of these endless planetary possibilities. A rock in your hand or in your lab is a record of geological processes that you can read and study and, importantly, share with different people who might have diverse approaches. I've enjoyed unraveling the story of rocks both big and small, from cosmic dust barely visible to the naked eye to outcrops of ancient Earth rocks many miles across. Meteorites have told me stories from the origins of the solar system and their time in the asteroid belt and even the environmental history of Mars. The need for more such stories led to decades of work in Antarctica, a place alien enough in its own right. And when that didn't provide the rocks needed to answer some questions, we used careful experiments to make some more. We've made Venus in a bottle with NASA Glenn's GEAR facility, subjecting volcanic rocks to the hellish physical and chemical conditions of that planet's surface. And we've cooked rocks in brine to try and understand what's going on deep underneath Mars's surface. We've made tiny little anvils and hammers out of meteorites to explore the fundamental stickiness of asteroidal materials. We've even tried to send a little tiny spacecraft out to a little tiny asteroid to see how it flexes and spins in the sunshine. While snooping around on Mars for the source of those Martian meteorites, we serendipitously discovered an astonishing crater named Jezero and suggested NASA send a rover there, and that's where NASA's Perseverance rover is roaming today. It's been astonishing fun to explore our solar system this way, made dramatically more so by all the wonderful students who have joined in on the fun. And I'm extremely grateful to be at Case Western Reserve University, where running off in wild new directions is encouraged, and doing something nobody's done before is considered a very good thing.